Welcome to lesson number 1 of linear and quadratic systems and inequalities. So in this unit we're going to solve systems of linear quadratic equations and quadratic equations. So what that means is if we are given two equations, one of them being linear and the other being quadratic, or both of them being quadratic equations, we want to solve graphically and algebraically where those two equations are going to have similar points on their graphs. So first of all, a linear quadratic system of equations is a system in which, again, one of the equations is linear. So we have one linear equation, and remember that linear equations take this form of y equals mx plus b, and the other is quadratic. Okay, so one of them is going to be linear and the other is quadratic. So if we have a graph, one of the lines is going to follow something like this, whereas the other one could follow something like that. And we would solve for these 2 points. So we want to know where on the graph do these 2 points exist. So when we determine the values of x and y, that satisfy both equations, and we have solved the system of equations. So let's look at an example. Class example number 1. So in calculus class, in order to determine the shaded area, so this area in here, in the diagram between the parabola x squared, so we have a parabola, and the equation of the parabola tells us that we're at y is equal to x squared. And then we're also given a line, and that line is y is equal to x plus 6. And so this line is our linear system, or linear equation. So it is first of all necessary to determine the points of intersection of the parabola and the line. So we want to know where these points are. So we could just look at that on our graph, and that's easy enough to do. And if we do that, we can use the intersect feature of the graphing calculator. Okay, so I've already gone ahead and I've plugged in both of these equations into my graph. I have y is equal to x squared, which will give me my shape of my parabola, and then I have y is equal to x plus 6, which is my linear equation. So when I go ahead and graph those, I'm going to get 2 lines on this graph. So I have my y equals x squared, which is right here, and then my linear equation, which is y is equal to x plus 6. So the next thing we want to do is use our intersection feature to find out where these 2 points are going to intersect. So on my first curve, I'm going to choose my parabola, press enter, and it'll give me the option for my second curve, and then my guess. So this point here is going to be at x equals 3 and y equals 9. So if I'm writing this as a coordinate, it's going to be 3 and 9. Now, there's another point where they intersect, so let's see where that is. So again, I'm looking at my first curve, which will be on this side, and then my second curve, that's okay there. And we make a guess, and we are told that it intersects at x equals -2 and y equals 4. So the coordinate of this point is going to be -2 and +4. So use the intersect feature of your graphing calculator to determine the coordinates of the points of intersection. So we found those coordinates at -2 and 4 and 3 and 9. Next, we want to use the method of substitution or elimination to determine algebraically where these points of intersection are going to be. So what we know is that we have 2 lines. We have y equals x squared, which is our parabolic function here, and we have y is equal to x plus 6, which is our linear function here. Now, when we're solving these algebraically, we're told that both of these are equal to y. So it would also be true if I said that y is equal to y, or that since y is equal to x squared, it's also going to be equal to y, which is x plus 6. Now, in doing this, I'm making this in an algebraic equation where all I need to do is balance out this equation and solve for my x's. So if I were to do that, I'm going to bring this over to the other side, so I'll have to subtract x from this side and this side, which will give me x squared minus x is equal to positive 6. Now I'll have to subtract 6 from this side and this side, which will give me x squared minus x minus 6 is equal to 0. Now once I have done this, now it's just a matter of factoring this equation and determining what my x values are. So I'm going to go up here, and if I were to factor this, I'm looking for two integers that multiply to give me negative 6 and add to give me negative 2. So I'm going to choose x minus 3 and x plus 2 is equal to 0. Alright, so if I were to FOIL this, I'd get x squared plus 2x minus 3x, which would give me negative x, times negative 3 times positive 2, which would give me negative 6. And so I have my 2 points, and that means that x is equal to positive 3 or x is equal to negative 2, which is good because if we looked at our points of intersection, I knew that I did have a point where x was positive 3, and I also had a point where x was negative 2. So far that looks good. But that still doesn't tell me the points of intersection, right? That only tells me where my x values are going to be. So all I need to do is plug this into my original equation. So if y is equal to x squared, then I want to plug in my value for y is equal to let's go, y is equal to 3 squared, and that is equal to 9. So when y is 3, then x is equal to 9. Or sorry, when x is 3, y is equal to positive 9. And then on my other equation, I had x plus 6, y equals x plus 6. And if I plug in my, my value for x there, I'm going to have y is equal to negative 2 plus 6, and y is equal to 4. Okay? So the next thing we want to do is verify that these points in our systems are correct. So I was told that I had the points 3 and 9 here, and negative 2 and 4. Now verify that these points are correct. You can go do this verification process by yourself. All you're really doing is plugging them back into your system of equations and making sure that it works for both equations. Now the solution to the linear quadratic system of equations, y is equal to x squared and y is equal to x plus 6, can be written as x is equal to negative 2, y is equal to 4, if I'm using these points here and here, or x is equal to 3 and y is equal to 9. And remember, we can write these as coordinates on our graph, which give me negative 2 and 4 and 3 and 9. And actually for this question here, verify that the points satisfy the system of equations. When you verify these, you want to plug both of the values into both equations. And so if I have my equations y equals x squared and y is equal to x plus 6, you're actually verifying 4 times, because you want to verify this for both values and this for both values. So up here I kind of just chose arbitrarily which equations to plug my my points back into, but down here when you're verifying, you want to verify with both equations. So I would want to plug in negative 2 and 4, so I want to verify this into this original equation, and I want to verify this into my original equation. And same thing on this side. I would want to verify both of them, just in case you're confused about which points you plug back in. Okay, and we're going to find once we do verify that that all 4 of them actually work. Okay, so let's move on to investigating the number of solutions to a linear quadratic system. Okay, so the graph, we're given another graph, And this one is y is equal to x squared minus x minus 12, which is shown on the grid. Algebraically, determine the points of intersection of the line y equals 3x and the parabola y equals x squared minus x minus 12. So the first thing they want us to do is sketch the line and then to plot the points of intersection on the grid. All right, so if I have x squared minus x minus 12, we know that we're going to be working with a line that crosses at 3x. Okay, so we're crossing at 3x, and if I solve this algebraically, x squared, I'm going to have to subtract 3x from this side, which would subtract it from this side as well, and we're going to end up with negative 4x minus 12 is equal to 0. Now, from this point, remember, all we need to do is factor, so we're looking for two integers that multiply to give us negative 12 and add to give us negative 4. So those numbers are going to be x plus 2 and x minus 6 is equal to 0. And so our values of x are going to be at negative 2 and positive 6. Okay, so let's see when x is equal to negative 2. We'll plug that back into one of our equations. Y is equal to 3 times negative 2, and that would be negative 6. So when x is negative 2, we should be at negative 6 right here. And when x is 6, plug this into one of our equations. Y is equal to 3 times 6. Y should be 18. Okay, so when x is positive 6, we are going to be way up here at 18. So 15, 16, 17, 18 here. Here we go. And we're going to want to draw a straight line here. So again, it's better to do this with a ruler than a pen. But since I don't have a ruler handy, I'm just going to use my pen. And that's what that line is going to look like. Okay, and before we even actually were to do it algebraically, what I should have done was drawn my graph anyways. And so where my lines intersect, so if this was my equation y equals 3x, to graph that, remember that it's in the form of y equals mx plus b. Okay, so if there is no value of b, so in this case it's y equals 3x, there's no value of b, that means that it's 0. So that's where it is crossing my y-axis at 0. Okay, so we were crossing our y-axis at 0, just like we're told in this equation. And remember the value of m, that is our slope. And so if we have a positive 3x, that means if we're starting at 0, then every time we rise, we're moving 3. So it would be 1, 2, 3, or sorry, every time it's rise over run, so we would rise by 1, 2, 3, and over 1. So 1, 2, 3, over 1, 1, 2, 3, over 1, which is how we get these points in the first place. Okay, so my points of intersection are going to be at negative 2 and negative 6, which we saw down here. And we're also going to have a point of intersection at 6 and 18. So that was the point up here. So this would satisfy both equations, finding these 2 points. Now what we want to do is repeat part A for the line y equals 3x minus 16 and the parabola y equals x squared minus x minus 12. So we're still using this parabola here, but now what we want to do is we want to use this new line of 3x minus 16. All right, and so using that line of 3x minus 16, the first thing we want to do is actually plot this line. So we know that this is in the form of mx plus b, y equals mx plus b. And so if I'm looking for my b value, remember that's where it crosses the y axis. And so we're crossing the y axis at -16. So we have a point right there. Now what we want to do is find out what the slope is, and we're told that the slope is 3, so we're going to increase by 3 and go over by 1. So 1, 2, 3, 1, 1, 2, 3, 1, 1, 2, 3, 1. Alright, and so that's what the beginning of our line is going to look like, and we would also go down and over the same way. 1, 2, 3, 1. So when I cross my graph here, it looks like I'm going to be crossing at this point up here. And I should use a straight edge for this. So my line is going to look something like that. Okay, so let's find our, looks like we only have a single point of intersection in this case, because if you look at, if we were to really zoom in on this point here, we would see that it doesn't actually cross the same line for my parabola. Okay, so let's set up our equation. X squared minus x minus 12 is equal to, in this case, 3x minus 16. And so what we want to do, remember, is balance out our equation. So we're going to be left with x squared minus 4x. If I add 16 to 12, negative 12, I'm going to be left with positive 4, and that is equal to 0. Now this is a perfect square, and so if I were to factor this, I would get x minus 2, and x minus 2 is equal to 0, or x minus 2 squared is equal to 0. And that tells me that x is equal to 2. So if I plug in x into my equation of 3x when x is equal to 2, if I plug that into my equation of y equals 3x minus 16, I'm going to get y is equal to 3 times 2 minus 16, or 6 minus 16, which is negative 10. So the point of intersection is going to be at positive 2 and negative 10. And so let's look at that on our graph. If I'm at positive 2 and negative 10, that's where I intersect. Okay? Now, part C. Repeat part A for the line y equals 3x minus 24. Okay, so x squared minus x minus 12. Let's do this first. 3x minus 24. Now, once I carry this out, x squared minus 4x, and if I bring this over here, I'm going to get plus 24, which would be plus 12, is equal to 0. So two integers that multiply give me 12, and add to give me negative 4. So positive 12, negative 4. I actually can't factor this, and so what we could use, A is equal to 1. I can use my quadratic equation. B is negative 4 and C is 12. That would be x is equal to negative 6, or sorry, negative b plus or minus the square root of b squared minus 4ac divided by 2a. So if I plug my known values into my equation, x squared is going to be 4 plus or minus negative 4 squared minus 4 times 1 times 12 divided by 2 times 1. I'm going to get x is equal to 4 plus or minus negative 4 squared is going to be 16 minus 28. 16 minus 28, or negative 16 minus 28 is going to be negative 32 divided by 2. And I can't divide by a negative, so that tells me that there are no solutions. Or sorry, I can't take the square root of a negative, so in this equation there will be no solutions. Now let's see why that's the case. If we graph, let's graph y is equal to 3x minus 24. Alright, so if we're graphing this equation here, then we're crossing the y-axis at negative 24, which is right here, and we're using the same slope of 3x, So 1, 2, 3, 1, 1, 2, 3, 1, 1, 2, 3, 1, and draw my straight line. So the reason there's no solutions is because these two graphs don't actually overlap, right? So if I look at my first equation, that was when y was equal to 3x. This was when y was equal to 3x minus 16. And this last line, sorry, that should be going there, but this last line was when y is equal to 3x minus 24, which we were told was there was no solution. And again, the reason there's no solution is because these lines don't actually intersect each other. Okay, so let's see what we just learned. If the graph of a linear equation and the graph of a quadratic intersect, and a quadratic equation intersect at 2 points, then the linear quadratic system has two solutions. Now, if those lines, the linear equation and the quadratic equation, only intersect at 1 point, then there's only one solution. And if they don't intersect at all, there's going to be no solutions. Okay, so let's look at this this next statement. If the resulting quadratic equation has two distinct roots, so two distinct x values, then the discriminant is going to be positive. So that means the discriminant being the square root. This would be positive. And then there would be two solutions. If the resulting quadratic equation has two equal roots, so in the case of our second equation when we had x was equal to 2, then our discriminant would actually be equal to 0. So if we were to plug all those in for our second equation, we would have a discriminant of 0, and there would only be one solution. And the last case, if there was a negative discriminant, then there's going to be 0 solutions.